All right, in this video, we are going to solve absolute value equations by graphing. So we just covered a unit on graphing absolute value functions, and now we're going to use it to help us solve some equations. So first off, the definition for absolute value, this is review of this vocab word, but it's a number's distance from zero on the number line. So if you remember, absolute value is two vertical bars. The absolute value of -2 is +2 because it's 2 units from zero on the number line. We talked about that a little bit last unit. It's important to know distance is always measured with positive numbers or zero. Basically anything greater than or equal to zero, that's a distance. The distance cannot be a negative number. So the question is, how are we going to use graphing to find the solutions to an equation? So here it is in words, and then we'll kind of demonstrate this through a couple of examples, but we're going to graph our absolute value function using transformations. So we're still going to go back to using those vertical and horizontal shifts. The solutions are going to be where the absolute value graph intersects the indicated value of the problem. So to understand exactly what that means, let's look at this first example. This one, we're solving the absolute value of x plus 2 equals 4. So up here, when we talked about an indicated value, our indicated value is 4. So we want to find out where this V-shaped graph is going to intersect at 4. So here are the steps on how to do this. Step 1, we're going to treat each side of the equal sign as an equation. So first off, I'm going to take the left-hand side, and I'm going to graph that function. So I'm going to graph the function f of x equals the absolute value of x plus 2. So I'm going to go ahead and do that down here. Of course, that's a V-shaped graph that's been shifted left 2. And then what I'm going to do is I'm going to take the other side of the function, which is, we've already circled as a 4, and I'm going to treat that as its own separate function. That's our indicated value. So we're going to set this function equal to 4. So f of x equals 4 is just a horizontal line where the y coordinate is always 4. We can graph as many or as little as 2 points. You'll notice this is the reason I did not connect the dots from the absolute value graph yet, because our goal is to find out where this graph intersects the indicated value of y equals 4. And if we continue just a little bit more with this graph, we will see where they intersect. So there's our graph. Step 3, we're going to find the x values, because remember, we're solving this equation for x. There really wasn't a y value or value in this problem to begin with. So our answers are the x values. We're going to write them in set notation. So my solutions here are x equals 2. Because they intersect right here where x equals 2. And they intersect again over here at x equals -6. It's just the x coordinates. So of course, the question here says, how many solutions did you find? We found 2 solutions. A lot of the times you're going to have 2 solutions from these graphs. And then finally, check it. You get in the habit of checking your answer. So we want to go back and we want to plug in both of these numbers into the original problem. So the first x value we're checking is +2. That we can see pretty quickly. Absolute value of 2 plus 2 is 4. The other solution is -6. Of course, -6 plus 2 is -4, and -4 has a distance of +4 from the number line. So those are indeed the solutions. Go ahead and pause the video at about the 5:25 mark. I'm going to show you the answer to U-Try 2. So here's the answer to U-Try 2. Really important when you do quizzes and tests that you actually show where they intersect. So you actually have an ordered pair there. So I can see you know that the solutions are where the two graphs intersect. All right, last one we'll do here in this video. We're going to solve an absolute value equation when the lead coefficient inside is greater than 1. So in this case, we've got step 1. We're going to do the same thing. We're going to set the left side We've done a little bit of this in the last unit, but I just want to refresh on this. And the right side is its separate function. Now remember, when we graph this one right here, we don't really have a transformation rule when the lead coefficient in front of x on the inside of the absolute value is not 1. So what we want to do here is we want to factor out that 3. We want to divide it out basically. So I'm basically just dividing the first term and the last term by that lead coefficient. And then I'm going to mark out the original problem just to show that we're not really looking at that anymore. So now we can graph x plus 3 times the absolute value of x plus 3. That's a left shift of a left 3 units. And the y values are stretched by a factor of 3. And then I'm going to graph this other function, f of x equals 6. That's, again, just a horizontal line. Right about there. And then you can see pretty clearly where these graphs are going to intersect each other. We've actually got those points plotted. So our solutions are here and here. We just need to figure out what the x coordinates are at those intersection points. So that's -1 and -5. I'm not going to go through the work of checking it. That's a habit you want to get into, especially on quizzes and tests. Go ahead and try that last one, the U-Try 4. We'll go over it here in about 5 seconds. All right, so just to make sure you got the part right where you factored out that 1/2. So our goal again is to have a lead coefficient of 1 in front of that x. That's what you should have gotten. So -6 and -10 should have been your answers. Of course, you had to extend the graph there a little bit, which made that one a little trickier. I'm going to show you later on in this unit how the graphing calculator can sometimes help with these problems that go way off the grid. Go ahead and try the last one, the U-Try 5, and then we'll come back and check that answer in just a moment. So you can see when you graph these two functions, they do not intersect. So that is, of course, a case where we get no solution. There's a couple different ways, really 3 different ways that this can be shown. You can actually write out the words, no solution, or you can write a 0 with a slash through it. Or you might see some in this unit, when you get to the test, they'll write the answer in set notation with nothing in it. An empty set is what it's called. And this last question is, okay, so why is there no solution? Well, think back as absolute value. Absolute value is a distance. What did we say at the very beginning that distance can never be? Distance cannot equal a negative number. You don't say you're -6 miles from the nearest gas station. You would say you're 6 miles. So absolute value cannot equal a negative number. It's important to note that the absolute value is technically not by itself here. So your first step would have to be divide both sides by 5, but it's still going to be a negative number on the right-hand side after you do that.